All right, so we're going to take a look at section 2.2 today. So it is split into two files, but we're going to put it all together in the video. And just a reminder that when we are solving a problem, sometimes we might use an algebraic approach, sometimes we might use a graphical approach, or we can combine the two. Okay? Generally, like for example, with a quadratic, when you're solving that, if they want an exact answer, a graphical approach isn't going to help because the graphing calculator is going to give you decimals. So if the answer doesn't come out nice, you'd have to use an algebraic approach, right? Quadratic formula. So we're going to look at some problems today that we kind of combine both approaches, maybe drawing a diagram, using the graphing calculator, along with setting up an equation. All right, so this problem says that Bill is going to invest $20,000. Now, the amount of money that Bill's investing is fixed, okay, $20,000. That doesn't change. But there are two different investments that he can put his money into. One investment is going to pay 6.75% interest. The other one is going to pay 8.6%. So he's splitting the money into two. Now, they tell you that in this problem, the money that Bill is going to earn is based off of simple interest. Okay? We haven't studied that, and this is not a finance class, so I would tell you what the formula is for simple interest. Okay? When you're trying to calculate the amount of money that you earn on an investment that is based on simple interest, it depends on three things. One, how much money did you put in the investment? That's the principal. R is the rate of return on the investment. When we write that rate of return, it has to be a decimal. So if they give you a percent, you need to change it. And the last one is T. That's the amount of time that you leave the money in the investment. Okay, with simple interest, generally the longer you leave the money in there, the more interest you would make back. So what we want to do is find an equation that represents the amount of interest Bill earns in 1 year from this problem. Now, the first thing we have to do is identify what the variable is going to represent in this problem. Okay. So, how many different investments is Bill using in this problem? I mean, yep, Ethan?
Two.
He's using two. So we have to let the variable be how much money he's investing in one of them. Because if we know how much money he puts in one investment, we know the total amount of money he has, then you should be able to figure out what's left for the other investment. So in our case, let's let X be the amount of money that Bill invests at the 6.75% investment. Okay, again, you do not want to pick a different variable for the other investment. The other investment's going to be in terms of X. Okay, so let's figure out how much interest Bill's going to earn in the first investment. We're going to use the formula I equals PRT. Okay, principal. That's how much money is put in the investment. How much money does Bill put in the 6.75% investment? Yeah,
X.
he puts in X. Yep. So there's our first one. What is the rate of the 6.75% investment? How about Jackson? What's the rate?
6.75%.
Yep, it is 6.75%, but we need to convert the percent to a decimal.
0.0675.
Good. 0.0675. Okay, so there's our rate. And how much time is the money, or how long is the money going to be in the investment for? Yeah.
So you,
Yeah, it's going to be 1 year. So in this case, we really don't need to put times 1, but I'm just showing you that's where it would go if it wasn't a 1. Okay, let's simplify that. How can I write that in a nice way that's a little bit more compact than what I have there? The interest is equal to, Jane?
I raised my hand.
Do you know how we would write that?
0.675x.
Yeah, that's kind of the standard way. We always put the coefficient in front. I just wrote it in that order because that was the order of the formula, PRT, right? 0.0675x. There's a formula that represents the amount of interest earned at the 6.75%. Now, let's do the same thing for the amount of interest earned at 8.6%. First thing is the principal. How much money is invested in the 8.6% investment? Yeah?
20,000 minus X.
Yep, 20,000 minus X. That's your principal. The rate of the 8.6% is lens? 0.086. And the amount of time, again, it's the same problem. We're doing it for 1 year. Okay, so let's clean that up by really distributing it out and putting it in like a y equals mx plus b kind of format. Okay, so the times 1 that has no effect on it, but let's distribute that. So negative 0.086x, that's the first part. And then I'm going to do 20,000 times 0.086. 20,000 times 0.086 gives me 1,720. Okay. That's the amount of interest that Bill would earn in the other investment. Now, the question was, find an algebraic representation of the interest earned in a year. Okay. We found the interest separately for a year. Now I want to find the total. How would I find the total amount of interest that Bill's going to earn? Yeah?
Do we just add the x's?
So can you explain to me what do you mean?
Combine the x's, so
From what?
both equations.
Right, you're going to add together both equations, and the only like terms you're going to end up with are the x's. So you're going to take the interest earned at 6.75% plus the interest earned at 8.6%. Just kind of an abbreviation of writing that down. So let's figure out, let's look up each formula. 0.0675x plus negative 0.86x plus 1720. So add that together, and that will give you your total interest. Okay, 1720, we don't have anything to combine that with. So we can just write that down. And then let's take 0.0675 plus negative 0.086. So it's negative 0.0185. What did I say? 0.0185. That formula represents the total amount of interest that Bill will earn for 1 year. And all you have to do is tell me X. Just remember that X is the amount of money invested at 6.75%. So you tell me that, I'll tell you how much money he's going to make for the year. Any questions on how we figured out that formula? Okay, so now they're going to ask us something about that. All right, so let's see what they want to know. Okay, so they're going to ask us a question, but we have to keep in mind something, especially if we use the graphing calculator, that there's a difference between a graph that shows everything that mathematically could happen, right? Like in this problem, mathematically, what's the domain of X here? What numbers mathematically are you allowed to fill in? Forget it's about a word problem. Yep.
All real.
You can fill in all real numbers. There's no square roots there. There's no fraction with a letter in the bottom. But when we think about this in the context of our particular problem, there is a restriction on X because it's an amount of money. Okay? So keep that in mind when we go to set up our window. Okay? We're going to want to set up our window in the context of the word problem. So it says, how much did Bill invest in each investment? Okay, each the 6.75 and I think it was 8.6. If he earned a total of $1,509.10 in interest. Let's do it algebraically first. How would I solve that problem? Algebraically, using what we just did in example 1. Raj?
You take the graph. You plug in the value of the graph.
Okay, what value are we plugging in?
The 1,500.
Okay, so the $1,509.10. Yep, we are going to plug that in. And where do we plug that in?
The equation for total interest.
We're going to plug that in the equation for total interest. So is it going to go on the left side or in for the X?
For the X. The other side of the equation.
Right, that's the dependent, right? This 1,509, that's a dependent amount. That depends on how much money he put in each investment. So that goes on the side where the dependent variable is. Okay, so we've got $1,509.10 equals negative 0.0185x plus 1720. Okay, so let's divide that out. So we got $1,509.10 minus 1720. Oh, sorry. 1,509.10 minus 1720, and then divide by negative 0.0185. 0.0185. Okay, so that gives me 11,400. Okay, first of all, what is that? 11,400 what? Yep. Dollars. And specifically in our word problem, that $11,400 is what amount? Yeah?
The amount that he invested out of the 20,000.
Can you be a little bit more specific? It is an amount of money that was invested.
Like out of the 20,000 that he put into both of them.
the 11,400 is, we need a little bit more info about that 11,400. Yeah,
It's the amount you put into the investment of 6.75.
yes. It's the amount that was invested at the 6.75% rate. So 11,400. So how much money does that mean was invested at the 8.6% rate? Yeah,
8,600.
8,600. It's the amount that's left over. There you go. Okay, so that's how you can solve it algebraically. Right, let's do the same thing graphically. Okay, so graphically, we're going to go back to the step that we had right there. How would I set this up on my calculator to be able to solve this problem graphically? What could I type in y1? Yeah.
So the left side of your equation, instead of 1,509, would have to be y here.
Okay.
And then
So what would you put right there?
I'd put negative 0.0185x plus
Negative.
1720.
Okay, we can put that in there. All right. And what else would you do?
Upon graphing it, I could search for the value. Actually, no, I wasn't sure value of x. Never mind. I could graph another line.
Yeah, you got to graph another line. Good. What other line do we need to graph?
It would be y equals 1509 10.10.
1509.1. Now, I said we got to think about our window a little bit. Can you invest a negative amount of money? No, that doesn't make sense. How about a maximum amount of money? What would the maximum amount of money be in this problem? Yeah, 20,000. He doesn't have more than 20,000. Okay, the Y min, that's the interest that you earn. Well, this type of investment, you can't lose money. It's not like the stock market where you could go negative. So 0 would be the smallest amount of interest you could earn. But what should my Y max be based on what we put in Y1 and Y2? That Y max needs to be high enough to see something. It's got to be at least what number? Lance?
Would it be at least like 1,720?
Yeah, I would do it at least to 1,720 so you could see the y-intercept on that first line. Yep, that's about what I would do. So I'm going to say 1,800. Okay, I'm going to go a little extra. Perfect. So there's the right side. There's the left side. And what would I do now? Got my two graphs? Ralph?
Do the calculation for the intersection.
Yep, we're going to calculate where they intersect. Because there's only two graphs on the screen, they're linear. They only cross in one spot. First curve, second curve, yes, none of them matter. So when you do the intersection point, you get 11,400, which is exactly what we got algebraically. Okay. So any question on solving, once we get it set up, solving that problem algebraically or graphically? Okay, so that's the first part of 2.2. All right, let's look at this one. So this is pretty similar. It's actually identical to the problem we did in the homework. It's just the perimeter, instead of being 360 like it was in the homework, is 100. So it says find an algebraic representation that describes the area of these rectangles. Okay, we're looking at all the rectangles that could have a perimeter of 100. So when we have a word problem, what's generally a good first step to help us think about the information that they give us in words. Yeah.
Like draw it out.
Yeah, let's draw it out, right? A lot of times if you have all these words and sentences, it's a lot easier if you can just see a picture. Okay. And what do we know about that rectangle? We know one thing about
Has
it.
a perimeter of 100.
Has a perimeter of 100. So what's the first thing that we could label in that diagram? How about Emma? What's the first thing we could label in that diagram?
One of the lengths.
Sure. Yeah, we could label one of the lengths as x. So if that's x, that's good. What else could we label? Yeah.
You could do the one on the bottom as x as well.
Okay, the one on the bottom has to be x. And now that we've labeled those two sides x, can anyone explain to me what that tells me so far? Yeah?
You know that the measure of the two side lengths must be 100 minus 2x.
Right. Okay, we've used up x and x for the material on the top and the bottom. That leaves us with 100 minus 2x units of material to build the other two sides, which means the right side. What's the formula going to be for the right side? Yeah?
50 minus x.
Yep. And the left side?
50 minus x.
Same thing. Now you've got your diagram. You're ready to describe the area of that rectangle. What's the area as a function of the length, which we are calling x? Yeah.
X times, in parentheses, 50 minus x.
So we got x times 50 minus x. There you go. So there's a formula for the area. And now it just says to find a complete graph. Right, so let's graph it. Let's clear that. Let's type in x times 50 minus x. Okay, x represents the length. Anybody tell me what kind of number does length have to be? How about Marin, what kind of number does length have to be? Yeah, it has to be greater than 0, so I'm just going to leave my x min at 0, so that's fine. What about my x max? There's definitely an x max in this problem. What's the x max? Look at your formula for area, and that should give you a hint at how big x could be. About, Gregor, you tell me.
50.
Yeah, x can't go bigger than 50 because then you'd have negative sides. All right. So I would set your x max at 50. And now y is area. Well, we can't have negative area. I don't think we're ever going to get an area as big as 1800. I don't know how big it's going to be. We could try going up to 800 and see what our graph looks like. That looks pretty good. So there's a graph of all the different areas you can get if you have a rectangle with a perimeter of 100. That's every possible area plotted on a graph. Okay? And obviously there's a maximum area somewhere. And does anybody remember what shape gives you the maximum area? Yeah?
Square.
Yeah, it's a square. If you're building a fence, or if you have a fence, the best shape you could make, if it has to be a quadrilateral, is a square. And that'll enclose the most amount of area with your fence. Okay. Now, if we could curve it and talk about circular shapes, that might be different. But at least for like a quadrilateral, a square is the best shape. Okay, so there's a complete graph. You would want to make sure you just tell me the window. 0 to 50 on the x, 0 to 800 on the Y. And if you did 0 to 700, that'd probably be okay too. I wouldn't do like 0 to 200 on the Y. Then you're going to cut off the vertex. Don't want to do that. Okay. Any questions on that? Okay. All right, so we're going to finish up 2.2, and we're looking at a little bit more with finding complete graphs. So we're going to start out with a word problem, and we're going to graph it and see if we can use that approach to solve it. So in this particular problem that we're going to do, it's going to be about a company or a business, and they have two kinds of costs. They have fixed costs and they have variable costs. Okay, an example of a fixed cost might be, for example, if you've got employees and you pay them a salary, right, at the school. Okay. The salary is once the beginning of the year starts, it's a fixed cost that they already know ahead of time for the salary of all the employees. But variable costs are things that could change that you can't always predict. Like in plumbing, they might not know exactly how many feet of copper pipe they're going to need. Right? They might have to buy more, or they might need more 2x4s, or they might need different materials. Okay, so materials are probably a variable cost, depending on how much of it gets used up, if mistakes are made, things like that. All right. So this particular company has a fixed cost of $200,000. Maybe that could be the cost for the company to maybe rent the space that they use for their warehouse. Right? Doesn't matter how much stuff is in the warehouse, they just pay $200,000 a year to have the space. And this particular company is making t-shirts, and they have a variable cost of $1.50 per shirt. And the reason it's variable is because it depends on how many shirts they make. So they have a cost of $1.50 per shirt, and then they sell the shirt to you for $4. So what we want to do is figure out a formula for the graph of the costs of the company has and the revenue. Now, the way that our book defines cost and revenue is cost is any amount of money that leaves your bank account you have to spend. Revenue is money that comes in. Revenue isn't necessarily profit. Okay. If you only sell one t-shirt for the whole year for this company, yes, you took in $4 in revenue, but is that actually profit? No, not if you paid $200,000 to rent the building, right? And the $1.50 it cost you to make that shirt. Okay, so cost is just money that the company spends. Revenue is what they take in. If we look at the difference, that's the profit. And profit could be negative if they don't sell enough product to make that the money. Okay, so let's find complete graphs of the equations for cost and revenue. Okay, so we're going to need a variable here. What's our independent variable going to represent? Yep.
The number of shirts made and sold.
Yep, the number of shirts that are made and sold. We'll assume if they make the shirt, they sell the shirt. Maybe this is a company that only makes the product when they get an order. Right? So whatever they make, they sell for shirts. And what's our dependent variable going to represent? For both cost and revenue, the dependent variable is going to represent, yeah?
Would it be the revenue?
And the revenue is measured in what?
Dollars.
Dollars, right? Cost, revenue, they're both money. Okay, so money is dependent in this case. Okay, let's start with the formula for the total cost. Okay, and let's use X for the number of shirts that we sell. So we're going to write the cost as a function of X. So since we didn't write that down, I'll make a note about what X is. Let X be number of shirts made or sold. It's going to be the same number. All right. Let's start with the variable part of the cost. How would we represent the variable part of the cost to make a shirt? Lens?
Would it be 1.50x?
Yeah, because that's what they say it is. The cost is $1.50 per shirt. So that's the variable costs. Now, what else do we have to put in that equation to account for the fixed costs? Yeah.
200,000.
And how would you write that part down here?
Plus 200,000.
Plus 200,000. Okay. So there's a formula for the total cost to produce shirts, the amount of shirts that you make. Now let's find a formula for total revenue. And again, this will be as a function of X, where X is the number of shirts that we sell. What would be my formula for the amount of money that's taken in? Okay, it's kind of like a formula for the amount of money that you could figure out should be in the cash register. That's basically what we're thinking of. Yeah, Marcelo?
That'd be 4x.
4x. Yep, that's the amount of money that the company takes in. Not saying it's all profit, but that's what they take in. Now, they want us to find complete graphs. Okay. Can anybody start to guide me through what I need to do to find complete graphs of both of those on the same screen? What's the first thing I have to do? Travis, tell me my first thing I got to do.
Go into y equals.
Yeah, I got to go to y equals. Perfect.
Then you want to clear out what you have in there.
Okay, and get rid of that.
And then you can put in the first equation, which is 1.5x plus 200,000.
Okay, plus 200,000. All right, that's good. Somebody else kind of keep going with that for me. What do I have to do next? Jackson, what do I do next?
Go to window and then to set the window.
Okay. And what would you set your x min to?
0.
0. And what does x represent again?
The amount of shirts.
Yep, amount of shirts we sell. What would be a good value for x max?
100.
100? Okay. And how about y min? What would be a good minimum for that?
0.
Yeah, 0. You can't have negative cost and you cannot have negative revenue. You can have negative profit. But neither one of these formulas would ever give you a negative number if x is 0 or higher. Right? And what about our y max?
200,100.
Okay, yeah, a little above 200,000. You could even, I mean, you could go just a little above it like that, or you could probably even do like 210,000. But yeah, as long as you're a little above 200,000, I think you'll be okay. I'm gonna I'm gonna go a little more just so I don't put it right on the edge of the screen. So I'm gonna just do 210,000. All right. Anybody else tell me what I need to do next? But Dario, what do I have to do next?
What'd you have to like put in the other equation?
Yeah, we haven't put the other equation in. We can set the window. We don't want to forget about that other equation. So let's put that in. All right, now I got them both in. Okay, now what do I do?
Graph it.
Yeah, now we're ready to graph it. Okay, so there's my line at 210,000. And there's my, well, it's not really a line. That's my costs, and that's my revenue. Okay, any thoughts on that graph? Yeah.
It's not complete.
Okay, yeah, it's not a complete graph. How come? What do you think we need to do?
You need to change the window so you're able to see the intersection.
Yeah, we need to see the intersection, which in this problem means we need to set what higher? Raj?
The X max.
X max, we need to sell more shirts. 100 shirts isn't going to cut it. All right, so let's bump that up to like 5,000 shirts. Now you can at least see your costs increasing. And I don't know if you can tell yet, but the revenue is increasing faster. Now, looking at that, what do you think we're going to need to do? Yep.
Increase the X more,
Okay. What do you want to make the X?
100,000.
100,000. Okay, so we're going to sell 100,000 shirts. Here's my cost. Here's my revenue. Okay, I can definitely see that they are sloped lines at this point. But now what do I have to do? Once I made X 100,000. Yep.
Change the Y max.
Yeah, we got to see higher. So instead of 210,000, let's go to like 350. Let's see if 350,000 is enough. I think, yeah, I think that'll be good. Yeah, that's good. So that is a complete graph. So don't forget to tell me the window. Put that with it. Not the only window, but it is enough that you can see the intersection point clearly, and that was the goal. All right, so we've got our graphs. Now, what's happening right there? Yeah.
That's when they like break even.
That's when they break even. Yeah, that's called the break-even point. So the break-even point is when the cost for making the product is the same as the amount of money that you made. So at that point, what is your profit at the break-even point? Yeah?
Just zero.
Zero, right? You haven't made any money. You haven't lost any money. Okay, you break even. So that's when the cost and the revenue are the same. So we just answered that. For a graph of cost and revenue, that point is the intersection. So it's the intersection point. So now let's find the number of shirts that the company has to sell in order to break even. Okay, so let's figure that out. All right, let's start by doing it algebraic. So remind me again, break-even point is where what equals what? Declan?
Where cost equals revenue.
Where cost equals revenue. So just look up your two formulas for cost and revenue. 1.5x plus 200,000 equals 4x. Okay, so we're going to have, when we subtract that, 200,000 equals 2.5x. So take 200,000 and divide by 2.5, and you get 80,000 shirts. So if they sell 80,000 shirts, what's going to happen to this company? Yep.
They break even.
They break even. They don't make money. They don't lose money. Yep. So that's how you can do it algebraically. Now, let's do it graphically. So one more time, I think we did it earlier, but can someone remind me, how do I solve this graphically? What do I press? Vanessa?
Second, and then trace,
Trace?
and then
5?
just hit enter.
Yeah, because they're lines, so there's only 2 of them on the screen. They only cross in one spot. It doesn't matter where we put the cursors. So the intersection point comes out to 80,000 shirts, which is exactly what we got doing it algebraically. Okay. So any questions on finding a break-even point? Okay. So that finishes up 2.2. So let me put the homework on the board. And then I had 31 to 34, so why don't we just make it 31 to 39. Okay, so that's the homework for tonight. That might be split into 2 different PDFs, so you might have to click on the 2.2 part 1 folder to get problems from the first page, although it might all have ended up on the same PDF. All right, so you got a little bit of time left, so please use the time to try to work on those questions. If you happen to finish it, which maybe you will, maybe not, you can come up and show me, and I will check that out.